Recrystallisation. So this is a process whereby you purify something like aspirin. So when we made aspirin, we purified it. So it's when a solid is purified, when it's impure and you purified it. Other solids that could be purified in the same way as aspirin are paracetamol or another one called benzoic acid. The solid that's got impurities in and you want to purify it. What you do is you get a liquid, a solvent. The solvent is a liquid that something will dissolve in, and it dissolves the impure solid. So you take the liquid solvent and you dissolve the aspirin in it. The solid shouldn't dissolve in the cold solvent. So in this case, let's imagine we've got aspirin and the solvent is ethanol. The aspirin shouldn't dissolve in the cold ethanol, the solvent, but it should dissolve in the hot solvent. So in other words, when we heat the ethanol up, the aspirin should dissolve, but it shouldn't do when the ethanol is cold. Impurities shouldn't dissolve at all. So what you do is you take the aspirin, you dissolve it in hot ethanol, and the impurities don't dissolve, but the aspirin does. So the aspirin will dissolve in the hot ethanol, but the impurities will not. We've got to use the minimum amount of hot solvent or hot ethanol, because what we want to do is we want to dissolve the aspirin in the hot ethanol. The impurities don't dissolve, so then we can filter off the impurities, and when we cool the hot ethanol, the impurities don't dissolve, filter them off, filter it while it's hot to get the impurities out. The impurities will stay on the filter paper, and the ethanol with the aspirin dissolved in it, filter it while it's still hot, so the solid aspirin stays dissolved. By the way, using vacuum filtration, reduced pressure filtration to filter off the impurities, so you can do it quickly whilst the ethanol is still hot. And then you're going to cool down the hot ethanol so that the aspirin comes out of solution. The filter paper in the Buchner funnel, that's that sort of triangular shaped funnel, has got to be flat so that the solution does not pass around the sides. That was an A-level question once a couple of years ago. And then, as I say, we cool the filtrate. The filtrate is the liquid that comes through the filter paper. In this case, it's the hot ethanol, and the aspirin passes through, and we cool it down. The easiest and quickest way to cool down the hot ethanol is to use an ice bath. And then, if it's cooled, then you're going to get some of the aspirin no longer able to dissolve in the hot ethanol, and some of the aspirin will appear. It's important to use an ice bath so that as much of the aspirin will come out of solution, no longer dissolve and appear as a solid, so you get a better yield. If it's still slightly warm, then some of the aspirin will stay dissolved. Crystals of your aspirin will then form because the aspirin can't dissolve in the cold ethanol. It can only dissolve when the ethanol is warm. And then you refilter it again using vacuum or reduced pressure filtration to get the solid aspirin out of the cold ethanol. Important to wash the crystals of aspirin to remove any insoluble impurities, and then your main impurity is now going to be water because you just washed it and it's wet, so you need to dry the crystals, and the easiest way is just to press them between two dry filter papers, and that will soak up most of the water, and it leaves the main impurity. It removes the main impurity, which I've said in this case is water, because you just washed it with water. So, filtration. What's filtration? Just as a recap, if you want to remove a solid from a liquid, you use filtration. That's better than decanting. Decanting is just where you pour the liquid off. So if I had a solid at the bottom of some liquid, say for example some sand at the bottom of some water, or in this case the aspirin at the bottom of the cold ethanol. Decant means you just pour the liquid ethanol or the water from the sand off, and that's just a quick and easy way to get the liquid away from the solid. So I could pour the ethanol away from the aspirin, but it's never very good, because as you're pouring the liquid off, then some of the solid comes off with it, so you end up with a low yield. So your best way to get a solid out of a liquid is use filtration rather than just pour the liquid out, which is called decanting, because some of the solid comes with it and you get a poor yield. Reduced pressure filtration using a Buchner funnel is useful because it's quick. It sucks the water out by reduced pressure or vacuum filtration and removes most of the water, the main impurity. If you then want to test the purity of the solid, the aspirin, you measure its melting point. You put the dry crystals into a melting point tube, a thin glass tube, and you put the thin glass tube into a melting point apparatus to measure the melting point. You know the pure crystals, they're pure if they melt at a sharp melting point, if they suddenly melt, and if the crystals melt close to the melting point of the paracetamol or aspirin. So you look up the pure aspirin or the pure paracetamol melting point in a data book, and if it's close to that melting point, you know that the paracetamol or the aspirin or whatever you're making is pure. The more impurities you are, then the lower the melting point. So say, for example, the melting point of aspirin is around about 135 degrees C. If it's very close to that, maybe 133 or 134 or even 135 degrees C, it's very pure. If it starts to come down to 130 or 128 or 125, it's getting less and less pure. And if it's above the data point value of pure aspirin, 135, if it then is 136, 137, 138, 139, 140, it can't be aspirin.